Okay, everybody, welcome to the last section, last topic of Unit 2. Unit 2 has been all about logic and proofs and introduction to proofs. Today, we're going to look at our first 6 real geometry proofs, and that'll give you kind of a taste for what we're going to be doing this year. And I got a lot of this written out ahead of time because otherwise it would take so long, but we got 6 proofs today we're going to look at. And you'll just kind of get the feel for it as we go along, but it's going to probably look new to you for a while. Okay, first of all, let's talk about a theorem. What is a theorem? A theorem is any statement that you can prove. Contrast that with a postulate, which we've had earlier in the year, where it was a statement you could not prove. So the difference is a postulate you cannot prove. It's just accepted without proof, and a theorem you can prove. Our very first theorem of the year is the linear pair theorem. Linear pair theorem. So theorems are presented in if-then form. So they're presented as a conditional statement, which we just spent a lot of time looking at. So here you go. Here's your first theorem, which is presented as a conditional statement. If two angles form a linear pair, then they are supplementary. If two angles form a linear pair, then they are supplementary. So I kind of did an informal proof here. I drew a little diagram for us to look at, and I wrote down some steps that hopefully we can follow. This is called deductive reasoning. We did inductive reasoning. Now this is deductive reasoning. Deductive reasoning is when you follow step by step to arrive at a conclusion. Okay, so usually the first step in a proof is going to be what's given, and that's the hypothesis. So we're given that two angles form a linear pair. So you see my first statement there. Angle A and B form a linear pair. Okay, so what do we know from that? Well, we know a linear pair is a pair of angles that add up to a straight angle. So our next statement in our proof can be angle A and angle B add up to a straight angle, because that's what a linear pair does. Definition of linear pair. Well, now that we know those two angles add up to a straight angle, what else can we say? Well, we can say the measure of angle A plus the measure of angle B is 180 degrees, because that's what a straight angle is. That's the definition of a straight angle. And now that we know that those two angles add up to 180 degrees, we can say they're supplementary. So notice that we started with the hypothesis that angles A and B form a linear pair. Remember when we underlined two angles form a linear pair. That's the first step. That's the hypothesis. And then we concluded the proof with the conclusion. So the two angles are supplementary. So that's what we did here on the last statement. So there's your first proof, kind of informal, but there you go. That's the linear pair theorem. If two angles form a linear pair, then they're supplementary. Okay. Okay, our second theorem of the topic, geometry proofs, is called the congruent supplements theorem. It says this: if two angles are supplementary to the same angle, then those two angles are congruent. So when you do a formal proof, and this is going to be our first formal two-column proof, you always have to be given something and you have to have something to prove. So the given in the theorem, look at the hypothesis. It says if two angles are supplementary to the same angle. So there's your hypothesis. So that's going to be your given in your proof. So I'm going to make up a little drawing here so we can attach some letters to it, some numbers. So if you look at my little diagram there, the given is that angle 1 and angle 2 are supplementary, and also that angle 2 and angle 3 are supplementary. So that's talking about the hypothesis. Two angles are supplementary to the same angle. So if you look at those two statements, both angles 1 and angle 3 are both supplementary to angle 2. So two angles are supplementary to the same angle. What are we trying to prove? Trying to prove that the two angles are congruent. So we're trying to prove angles 1 and 3 are congruent because they're supplementary to the same angle. Okay, so here's our first formal two-column proof. So in a two-column proof, you have two columns, all right? A statements column and a reason column. And we mentioned before that every statement has to have a reason. If you got 5 statements, you must have 5 reasons. Every statement must have a reason. So your first statement is always going to be what you're given. So if you can't think of how to start your proof, just write down what you're given. So we're given that angles 1 and 2 are supplementary and angles 2 and 3 are supplementary. So I just recopied that in the first statement. It's okay to do some abbreviation here as long as we know what the abbreviation stands for. So we know that we're given angles 1 and 2 are supplementary and angles 2 and 3 are supplementary. So we just write across from that given. The reason is given. Now look at statement number 2. We're saying the measure of angle 1 plus the measure of angle 2 is 180. That comes directly from statement number 1, knowing that they're supplementary. Also, I got a second statement here in statement number 2. The measure of angle 2 plus the measure of angle 3 is 180. Again, that comes directly from step 1. If we know two angles are supplementary, we know that their sum is 180 degrees by definition of supplementary angles. That's our reason. Definition of supplementary angles. Now, look at these two statements taken together. We know that angles 1 and 2 add up to 180. We know that angles 2 and 3 add up to 180. So wouldn't angles 1 and 2 be equal to angles 2 and 3? Because they both equal 180? So we write that in statement number 3. The measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3 by substitution. That's our reason. The sum of two angles add up to 180. The sum of two other angles add up to 180. So they both add up to 180. So those two sums are equal to each other. That's statement 3 by substitution. Now look at statement 4. How do we go from statement 3 to statement 4? Well, just look at it's an equation. Think of some algebra, just subtracting angle 2 from both sides. So if you subtract the measure of angle 2 from both sides, you have left the measure of angle 1 equals the measure of angle 3 by the subtraction property. And then to go from statement 4 to statement 5, we're just saying, well, the measure of angle 1 equals the measure of angle 3. So that means that angle 1 is congruent to angle 3 by definition of congruent angles. Definition of congruent angles. So we used a couple of different definitions there and a couple of different properties to accomplish our proof. So that's the proof of this congruent supplements theorem. And by the way, once we prove a theorem, we never have to prove it again. So once we put in the work, we just use it. We don't have to prove it over and over and over again. Okay, that's the congruent supplements theorem. Very similar to that is the congruent complements theorem. So the congruent complements theorem says if two angles are complements of the same angle, then the two angles are congruent. So again, I'm going to take that statement, pull out the hypothesis, and call that the given. So remember, the hypothesis is the part that follows the if. So the hypothesis is two angles are complements of the same angle. So looking at my diagram, I'm saying that angle 1 is a complement of angle 3. Angle 2 is a complement of angle 3. So I'm saying that angles 1 and 2 are complements of the same angle, namely angle 3. What are we trying to prove? We're trying to prove that the two angles are congruent. So in the context of our problem here, we're trying to prove that angles 1 and 2 are congruent to each other because they're complements of the same angle. Okay, I'll do another formal two-column proof. We know what's given. We know what we're trying to prove. We got our roadmap here. So again, if you're stuck, your first statement is just recopy the given. So we're going to recopy angle 1 and angle 3 are complementary. Angle 2 and angle 3 are complementary. It comes directly from the given, and so the reason is given for statement number 1. Every statement must have a reason. Okay, so how do we get statement number 2? Well, we know that angles 1 and 3 are complementary, so we know that their measures add up to 90. So the measure of angle 1 plus the measure of angle 3 is, the measure of angle 1 plus the measure of angle 3 is 90 degrees. Likewise, the measure of angle 2 plus the measure of angle 3 is equal to 90 degrees because of definition of complementary angles. Right? Because we know the complementary angles add up to 90. Okay, now we're going to do the same thing that we did before. Take these two statements and put them together. So angles 1 and 3 add up to 90. Angles 2 and 3 add up to 90. So angles 1 and 2 add up to angles 2 and 3, are equal to the sum of 2 and 3. So the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3 by substitution. How do we go from statement 3 to statement 4? Well, subtract the measure of angle 3 from both sides. So if you subtract the measure of angle 1, if you subtract the measure of angle 3 from both sides, you're going to end up with the measure of angle 1 equals the measure of angle 2 by subtraction property. So that's the reason. And then to go from statement 4 to statement 5, the measure of angle 1 equals the measure of angle 2. From that, we can say that angle 1 is congruent to angle 2 by definition of congruent angles. So the proof is almost the same as the one just before it. So we just proved the congruent complements theorem. And now we got several theorems that we can never forget. Okay, this one's called the right angles theorem. It's one of the easier ones we have this year. The right angles theorem says that all right angles are congruent. All right angles are congruent. Maybe that's obvious, but it's a theorem and you can prove it. So I'm just going to do an informal proof. I won't do a 2-column proof. So you see, by the way, you can write that as a conditional statement. If 2 angles are right angles, then they are congruent. So I made 2 angles that are angles A and B, and I said that they were right angles. That comes directly from the hypothesis. If 2 angles are right angles, then they are congruent. So we're given that 2 angles are right angles, A and B, and then we're trying to prove that angles A and B are congruent. Okay, so how would we do this proof? Well, start with the given. Angle A and angle B are right angles. You can see that I'm working right here. Angle A and angle B are right angles. That comes directly from our given. That's your hypothesis. Okay, so the measure of angle A is 90. The measure of angle B is 90. How do we know that? Because the statement right above it says that A and B are right angles. So that we can say that second statement by the definition of right angles. Now we say that the measure of angle A is equal to the measure of angle B. Why can we say that? Because the measure of angle A and the measure of angle B are both 90 degrees. So they're equal to each other by substitution. And once we know that the measure of angle A is equal to the measure of angle B, then we can say that angle A is congruent to angle B. And that's what we tried to prove. So we just proved the statement, all right angles are congruent. Or another way to say it, again, as a conditional, if 2 angles are right angles, then they are congruent. Okay, I think there's 2 more to do today. I am going kind of fast here, but you can always replay the video, right? Okay, so the vertical angles theorem is used all year long, and it's easy to use. It's 4 words long. Some of our theorems are really long this year. This is 4 words. Vertical angles are congruent. So just as a refresher, vertical angles are 2 angles that are across from each other when 2 lines intersect. So if you look at this drawing I got here, you got 2 pairs of vertical angles. Angles 1 and 3 are vertical angles, and angles 2 and 4 are vertical angles. So we could again write this as a conditional. We could say if 2 angles are vertical angles, then they are congruent. So our given is that angles 1 and 3 are vertical angles. We could have also chosen 2 and 4, but I just chose to prove to use angles 1 and 3. So we're given that angles 1 and 3 are vertical angles, and we're trying to prove that they're congruent. Okay, this is our first theorem. We're going to use other theorems to prove it. You might have a little tough time following this, so see if you can do that. Statement number 1, remember, is always going to be what's given to us. We're given that angles 1 and 3 are vertical angles. So that's the statement. The reason is given. So what do we know from that? Well, look at your diagram. Angles 1 and 2 are a linear pair. Right? They add up to a straight angle. So are angles 2 and 3 a linear pair? They add up to a straight angle. It's the definition of a linear pair. It's 2 angles that add up to a straight angle. So your reason for number 2 is definition of a linear pair. Okay, now here's where we use a previous theorem we just had. Look at statement number 3. We claim that angles 1 and 2 are supplementary. And we claim that angles 2 and 3 are supplementary. Well, look at statement 2. You remember the linear pair theorem? The linear pair theorem said that if 2 angles form a linear pair, then they're supplementary. we stated in statement 2 that two angles are a linear pair, and the theorem we proved first, our first theorem this year, is that if two angles form a linear pair, then they're supplementary. So now we know that angles 1 and 2 are supplementary by the linear pair theorem. We also know that angles 2 and 3 are supplementary by the same linear pair theorem. Okay, so we use the linear pair theorem to prove the vertical angles theorem. Okay, look at our last statement. Angle 1 is congruent to angle 3. Remember, that's what we're trying to prove here. Angle 1 is congruent to angle 3. And we're going to use that congruent supplements theorem that we had earlier. Look at statement number 3. You see that angles 1 and 3 are supplementary to the same angle, 2. And the congruent supplements theorem says that if two angles are supplements to the same angle, then they're congruent to each other. So that allows us to say that angles 1 and 3 are congruent. We did not have to prove that theorem over again. We just used it in this proof. So what we just proved was that vertical angles are congruent, and we used two previous theorems that we just proved earlier today to prove it. So again, vertical angles are congruent. That's what you're trying to prove. We never have to prove this again. We're just going to use this to prove other proofs. Okay. We got one more theorem. That'll wrap it up for today. This theorem doesn't have a name. It doesn't have a name. It's not very famous. It says this: if two congruent angles are supplementary, then each angle is a right angle. Think about that. If two congruent angles are supplementary, then each angle is a right angle. So I drew a little picture there for us for the visual learners. We're given that angle 1 is congruent to angle 2. That's part of your given, right? If two congruent angles. And we're also saying that they're supplementary. So our if statement is that two angles are congruent and they're supplementary. So that's all written in the given. What are we trying to prove? Well, look at the then statement. We're trying to prove that each angle is a right angle. So we're trying to prove that angle 1 and angle 2 are right angles. So again, the given comes from the hypothesis, and what you're trying to prove comes from the conclusion. So I'm just going to do an informal proof here. I won't actually write out the two-column proof. So look at the fact that we know that angles 1 and 2 are supplementary. So that allows us to say that the measure of angle 1 plus the measure of angle 2 is 180, but that's the definition of supplementary angles. If we know angles 1 and 2 are supplementary, we know that their measures add up to 180 by definition of supplementary angles. Look at this next statement. The measure of angle 1 is equal to the measure of angle 2. Why can we write that? Because back up in the given, we say that angles 1 and 2 are congruent. So this statement here is definition of congruent angles. So the measure of angle 1 equals the measure of angle 2 by definition of congruent angles. Now this looks weird here. The measure of angle 1 plus the measure of angle 1 is equal to 180. So remember, back up in this statement right here, those two angles measures are equal. So we can put in one for the other. So we can put in angle 1 right here. We can put that right here in that top equation. So that'll give us a measure of angle 1 plus a measure of angle 1 is equal to 180 because we made a substitution. So that's the reason, substitution. And then these are like terms. So the measure of angle 1 plus the measure of angle 1 is just 2 times the measure of angle 1. That's just like taking x plus x is 2x. So our reason for that is just algebra. Same thing here. Well, actually, we can call that the division property. So we take this statement, 2 times the measure of angle 1 equals 180 degrees, and divide both sides by 2. So that's the division property of equality. So we get the measure of angle 1 is equal to 90 degrees. Well, do you remember up here we said the measure of angle 1 is equal to the measure of angle 2? So now we know the measure of angle 2 is also 90 degrees. So once we know that an angle has a measure of 90 degrees, we know it's a right angle. So now we can claim that angle 1 and angle 2 are right angles, which is what we were trying to prove the whole time. Okay. So we just proved that theorem that if two congruent angles are supplementary, then each one must be a right angle. Okay, so you got a lot to absorb there, and we just did our first 6 proofs. We saw that we used definitions and even other theorems to prove new theorems, and you'll use some of these to prove other theorems later on in the year. So in geometry, you're never allowed to forget any theorems. Okay, we're going to get tons of practice with it this year. So that's it for the day. And go ahead and check out that assignment on geometry proofs. It's in Google Classroom.